Hello, I'm Richmond Baggins, and welcome to our physics tutorial. Before we delve into the topic, we're going to talk about, we should clarify what we're specifically going to cover in physics. We are going to cover the part of physics which is kinematics, which is basically the physics of motions, as kine is Greek for motion. Alright? So, this tutorial will be really simple and we shouldn't have a lot of trouble with this. So what we're basically going to be covering is the three laws of Newton. Now, everybody remembers Newton. It's that guy who was relaxing beside a tree with the anecdote of the apple falling on his head, which gave him the idea of gravity. Well, after this, he decided to lay a sort of foundation for physics and give us these basic three laws of motion. In this tutorial, we're basically going to give you guys a little synopsis of these three laws. Start with the first law of motion that Newton, or Sir Isaac Newton as he was accurately drawn right here, stated, which was that an object that will remain in place unless acted upon an outside force. Likewise, with an object that's in motion will stay in motion, and I forgot to put out the part, but an object that will stay in motion will remain that way unless acted upon an outside force. Now, this sorry. Now, this law has this law has a lot of to do with the two components of inertia and the vector quantity velocity. Now, as we have to learn that the quantities and velocity would shift as acted upon by an outside force, as since velocity is a vector quantity, it involves both speed and direction. Oops, sorry guys. Yeah. So if when an outside force acts upon the velocity of an object, then the direction will change and also the speed too. So the velocity would generally change. And this law basically states that an object that is in an inertial state will remain in that state unless a certain amount of force is acted upon it. And an object that is traveling at its terminal velocity, and terminal velocity basically means that where it just basically stops accelerating. As you know, when a car starts, it starts going like 20 kilometers an hour, then so on and so on until it stops at a certain speed. Well, an object that's traveling at its terminal velocity will remain at that constant speed unless acted upon an outside force. Because if you rearrange, and this I'm gonna delve into this equation much more later, but if you arrange F equals ma, where F equals force, m equals mass, and a equals acceleration. Sorry, that's very high. Acceleration would increase depending on the amount of force, you put onto the object, because if you rearrange this, it would equal a equals F divided by m. So the acceleration would change depending on the amount of force you put into it.
So if you're still asking yourself, what is this supposed to mean? Let me explain to you. So first, basically, it's telling us that an object will not move unless someone or something moves it. So take two TVs. TV A and TV B. Let's say TV A has 60 kilograms and TV B has 40 kilograms. Now, it doesn't matter whether TV A has more kilograms than TV B. None of these two objects will not move unless someone or something moves it. So, for example, if a person were to move TVB, then it would move. So basically, if an object doesn't move, it will move.
Well, the second law of motion is more on the specifics of the equation, force equals mass times acceleration, as I explained earlier. The second law states that the acceleration depends on the net force acted upon the object. And then this is like my little drawing of Tom Cruise saying the need for speed. And like, I should be an artist instead of a physicist, right? I mean, like, look at this beholding masterpiece. And I'm just kidding. So funny thing about it is that he looks like he's a janitor rather than a co-pilot for the movie Top Gun. Uh, well, enough about my bad drawing. Let's go back into physics, right? Okay, so the this law pertains more on the specifics of equals force divided by mass, and I'll just write it down right here. There you go. As you can see, the larger the force, the faster the acceleration. But then depending on the mass, the more force you would need to move the object or get the object to accelerate at a certain rate. Like imagine if you're inputting, because force is measured in newtons. Imagine you're inputting a force of uh like, like 20 newtons, and the object has a mass of 10 kilograms. That would mean that the acceleration of the object would be 2 meters per second squared, and we're just throwing in units, we're just plugging in some units just because. um so that's basically what I mean. That's what I mean by the more force you put into the object, the faster the acceleration, and it also all depends on the mass. This involves the component inertia, which I forgot to explain earlier. As wait, let me write it down. Inertia is basically the resistance of motion. And the law of inertia is that the more mass an object has, sorry, I want to circle it, is the more inertia it has. So if an object has a lot of inertia, the more resistant it is to move. Thus, would need more force to make the object accelerate. That's why it all depends on the mass.
If you still don't understand the concept, then let me explain. So, take two potatoes, potato A and potato B. So say potato A has 20 kilograms, while potato B has 5 kilograms. So the question is, which would be easier to move? So obviously, potato B would be easier to move since it has less mass. But if you want the scientific answer, potato B would be easier to move as it has less inertia. Less inertia means less force is required to move it. So if you were to move potato A, then you would need 4 times the force to move potato B to move potato A. Now I'm going to explain the equation. So take a car that measures 20 kilograms of mass and goes at a speed of 10 meters per second squared. And a man is trying to push the car. Now, how much force is needed to push the car? So, you would take the equation, force equals mass times acceleration, and that would be 20 kilograms multiplied by 10 meters per second squared, which would equal 200 newtons. So, for the man, we need to exert a force of 200 newtons to push the car.
So what the third law of motion basically states is that with every action, there is an opposite and or, if you guys can't read that because that looks so messed up, equal force acting upon the object. Now, here's an example. Take a person, the box into the air.
um, this well-drawn person. Let's say this person is exerting a force of 5 newtons. Now, as Newton said, with every action, there's an opposite and or equal force acting upon the object. In this case, that would be gravity. While the stick man is exerting a force of 5 newtons to lift the box, gravity is also exerting 5 newtons of force onto the box, but in the opposite direction.
So to recap, Newton's first law of motion. Newton's first law of motion. Sorry, guys. Newton's first law states that any object that will stay in place will stay in place unless acted upon by an outside force. And then any object in motion will stay in motion unless acted upon an outside force. And this is where they're in constant speed, and this is where they're staying in place unless they've been acted upon an outside forces, like someone kicks it, something like that, and it goes that way. Or, I mean, not that way, that way. Okay.
Now, the second law states that the acceleration depends on the net force acted upon the object. So this law focuses more on force equals mass times the acceleration.
This is great. And Newton's third law basically states that with every action like gravity, which exerts a certain amount of newtons, there will always an opposite or equal force acting upon the object, like so, creating a net force of 0. I'm Richmond Baggins.
And I'm Calvin.
Thanks for watching.